Hey everybody, today I'm going to talk about a pretty simple piece of code that I wrote that evaluates Boolean expressions. This is a problem that's been solved a million times before, and basically I'm going to show you an example of it that has no bells and whistles. The entire main module for creating basic Boolean expressions was less than 100 lines of code, and it demonstrates some kind of cool Python concepts in a very clear way because it's a fairly simple problem that lends itself well to Python. So before I dive into the code, I'll show you how it's used. So basically, here's a good example where you basically want to create a Boolean expression out of variables x and y. You use the symbol helper to create them, and then the actual expressions you can build up in Python in a very natural sort of way, like here. And then those expressions can be stringified. Those expressions can report what symbols they are constructed over. And then you can evaluate the Boolean expressions by supplying the list of variables that you are saying are assigned to true, and then the expression in turn will be evaluated based on those assignments. So for example, if your Boolean expression says not x, and by the way, the tilde just means not, the vertical pipe means or, and the, I guess there are no ampersands in this example, but an ampersand means, I guess up here you can see the ampersand. An ampersand means Boolean and. But going back to here, you can see that the expression not x, when you evaluate it with x being true, then that expression, of course, is false. And then maybe a little more subtle here is that if you evaluate the expression y and the only variables that you're assigning to true are x, then that will, again, evaluate to false because y has not been set to true, and sort of implicitly. So I'll take you into the module. Like I said, it's fewer than 100 lines of code. To be precise, it's 94 lines of code, including white space. And this is just a basic, this is a classic use of inheritance in Python. And I think this is a good time to use inheritance. I think inheritance is sometimes abused, but it's very natural in this context. You can see that the basic expression class mostly provides sugar. So Python has these magic methods. Some people call them dunder methods because dunder is short for double underscore, and the convention in Python is that you surround the English word with double underscores when you have a method in Python that is sort of magically used by Python. It's not like magic, but it's Python does special case these. So basically, this and here is telling Python that any object of this type can be combined with another expression object using the actual ampersand operator in Python. And I can go back here to show you an example of that. For example, you could construct it like that. And then what this automatically does is just create an and pair object, which I will show you in a little bit. Likewise, the or special operator means that the pipe, combining two expressions with a pipe, will create an or pair. Inverting, which is the tilde, will create a negated. And then any expression can return the symbols that are used in the expression. And the only reason I put that in the superclass is to avoid having to implement that in true val, which you'll see in a sec, and false val, because both of those just return an empty set, so they don't have to override that. The true val class is just a subclass of expression, and it's really small, of course. And the only thing it does special compared to the other classes is it stringifies itself as t. And if you evaluate it using any variable assignments, which we basically use the convention of the underscore to say that we don't need to use that, it'll return true, and false is very similarly constructed. Negated gets a little more complicated because you do have to contain the node that you are negating. But you can see these are all still one-liners. So when you stringify a negated expression, you stringify the underlying expression and prefix it with a tilde to get the symbol as well. Negating an expression doesn't change the symbols that the expression makes sense to evaluate over. And then finally, the evaluation is literally using a Python knot on top of our own evaluation of the underlying expression. And I think I'm going to stop with the real deep dive on this code because you can read this code and understand it, I think. And then the final thing I'm going to show you, and I think this might be the most interesting part for people who have already seen this type of code before, is just how I construct the tests. So I have this module called test basic, which is just testing my basic implementation of Boolean algebra. And the one kind of cool thing that I do down here is I try to generate an example of an expression in X and Y for every possible distinct type of Boolean expression over X and Y. And I don't call it out here explicitly, but there are basically 16 possible ways that a Boolean expression can be distinct from each other. And this has to do with two Boolean expressions are equivalent if and only if they evaluate to true for the same subset of variable assignments over X and Y. And again, I'm not going to do too deep a dive on that, but you can read the code here. I'll try to remember to put a link to this in the YouTube comments, but the repo is called Boolean Algebra, Boolean-algebra, and it's under my username, showell. Okay, I think that's it for now. I hope you enjoyed this video.